Good morning, class. Welcome back to the online classes. This is Mrs. Mukherjee. I'm doing exercise 2B now, continuing with the exercise 2B. Question number 6. Question number 6 asks you to simplify. Fifth root of x to the power 20, y to the power minus 10, z to the power 5 is divided by x to the power 3 and y to the power 3. We have to simplify this. So if it is fifth root, it means x to the power 20, y to the power minus 10 and z to the power 5 whole to the power is 1 upon 5 divided by x to the power 3 upon y to the power 3. Now when it is whole to the power 1 by 5, it means all the exponents are multiplied by 1 by 5. Each one you have to divide by 5. So when I divide x to the power 20 by 5, it becomes x to the power 4, y to the power minus 2 and z to the power 1. This division sign gets converted to multiplication. It becomes y to the power 3 upon x to the power 3. Now x to the power 3 and x to the power 4 you can reduce. So 3 and 4 when you reduce it remains as x. It is y to the power minus 2 and y to the power 3. This is multiplication, so we add. So 3 minus 2 is 1 and z to the power 1. When the exponent is 1, we can simply write it as x, y, z. So this is your answer. You have simplified it. This is the answer of question number 6, part 1. Now, I move on to question number 7. Question number 7 is simplify and express as positive indices. So first, the question is a raised to the power minus 2b whole raised to the power minus 2 multiplied by a b whole to the power minus 3. Now first I convert this into positive bracket. First I will multiply this. It becomes a to the power 4, b to the power minus 2. Minus 2 into minus 2 gives 4 and minus 2 multiplied by a to the power minus 3, b to the power minus 3. Now the negative exponents we know how to write. It becomes the reciprocal. So it is a to the power 4 upon b square multiplied by, both of this will become a denominator, 1 upon a to the power 3, b to the power 3. This too is division. So here it becomes a division. So 4 and 3 when we divide, it becomes a to the power 1. Now b square and b3 are both denominators, so both are getting multiplied. So we add them, it becomes b to the power 5. So your final answer becomes a upon b to the power 5. Okay. Now let's move to the next question. Question number 7, part 4. Question number 7, part 4. 32x raised to the power minus 5 upon 243y to the power minus 3 whole to the power minus 1 upon 5. Now 32, we can write it as 2 to the power 5, x to the power minus 1 minus 5. 243, I can write it as 3 to the power 5 and here it is y to the power minus 5 whole to the power minus 1 upon 5. Now when it is multiplied by minus 1 upon 5, what we do? We will multiply the exponent with this. So 5 into minus 1 upon 5 gives you minus 5 upon 5, which is minus 1. So it is 2 to the power minus 1. X to the power minus 5 into minus 1 by 5, negative negative gets cancelled, 5 divided, so it is x to the power 1. Same way here, 3 to the power 5, when I multiply with this, it becomes 3 to the power minus 1 and y becomes plus. Now this is negative, these are positive. So only this 2 and 3 will become reciprocal. So it becomes 3 by 2 x upon y. So 3x upon 2y is your answer. Now we move to question number 6 of question 7. X y raised to the power m minus n. So this can be written as x raised to the power n minus n multiplied by y raised to the power m minus n. Again multiplication sign, y raised to the power n minus l and z raised to the power n minus l. Again multiplication sign, z raised to the power l minus m and x raised to the power l minus m. So wherever now the base is same, we add the exponent. So x and x we will add. So it is x raised to the power m minus n plus l minus m. Same way with y to the power m minus n plus n minus l and z to the power n minus l plus l minus m. Now plus m minus m gets cancelled, so it is minus n plus l. You can write it as l minus n, l minus n. Same way y minus n plus n gets cancelled, so it is m minus l. Z, l and l gets cancelled, so it is n minus m. We cannot do anything further. We can leave it as it is, or if you want you can bring down the negative exponent, but I think this much is enough to write the answer. Or it is x to the power minus n, so you can bring it as x to the power l upon x to the power n. It will become a little more confusing for you, so you can leave it as it is also. Because together we don't know the value of L, M, N, etc. So we don't know whether the exponent is positive or negative. So we can leave it as it is. Okay. This is how you can leave your answer of question number 7 part 6. Now I move to question number 9. Question number 9 is x to the power 5 plus n into x square whole to the power 3n plus 1 upon x to the power 7n minus 2. Here what we have to do is to evaluate. It means find the value or solve it however you can. So x to the power 5 plus n multiplied by, here I will open the bracket, so it becomes 2 into 3 is 6n, 2 into 1 gives you 2 upon x to the power 7n minus 2. Now what will you do? Base is same, so I add. So 5 plus n plus 6n plus 2 upon 7n minus 2. 5 plus 2 is 7, so x to the power 7, 6 plus 1 is 7, so 7n upon x to the power 7n minus 2. Now this is division, so we can divide, and I will take all this exponent as the numerator. So I will write first this 2, that is 7 plus 7n. Now when the entire thing goes, we know that we subtract in division, so you put a subtraction sign and write the entire thing in bracket to avoid any confusion and do any mistake in the change of sign. Now you open the bracket, x plus 7n minus 7n, minus into minus becomes plus. So the 7n and 7n gets cancelled, so it is x to the power 7 plus 2 is 9. So this is what is the answer. Find the value. So first what I did is opened the bracket simply, then added the exponent, then because it is division, subtracted the exponent, changed the sign afterwards, and get the answer x to the power 9. Question number 12. You have to prove 1 upon x plus 1 plus x raised to the power a minus b plus 1 upon 1 plus x b raised to the power a equal to 1. Now I will prove the left hand side first. It should be equal to the right hand side, which is equal to 1. So the left hand side is 1 upon 1 plus x a minus b plus 1 upon 1 plus x raised to the power b minus a. Now I take the LCM. When I take the LCM, this is multiplication. So 1 plus x raised to the power a minus b multiplied by 1 plus x b minus a. And this goes as cross multiplying. 1 plus x b minus a plus 1 plus x raised to the power a minus b. Now you add this 2. So 2 plus x raised to the power b minus a plus x raised to the power a minus b. We can't do anything here because this is a plus sign. I leave it as it is. Move down to the denominator. You have to multiply. Open the bracket. First number multiplied by the second number. We get 1 multiplied by 1 plus x raised to the power b minus a. So 1 multiplied by 1 plus x raised to the power b minus a, and the second number, which is x raised to the power a minus b, multiplied by 1 plus x raised to the power b minus a. Numerator is written as it is. So it is 2 plus x raised to the power b minus a plus x raised to the power a minus b upon, open the brackets, it becomes 1 plus x raised to the power b minus a plus x raised to the power a minus b plus, when you multiply these two, now the base is same, so you can add the exponent. So x raised to the power a minus b plus b minus a, which is equal to 2 plus x raised to the power b minus a plus x raised to the power a minus b upon 1 plus x raised to the power b minus a plus x raised to the power a minus b. Here this a and a gets cancelled, b and b gets cancelled. So x raised to the power 0, and any number raised to the power 0 is 1. 1 plus 1 gives you 2. So it is, numerator is 2 plus x raised to the power b minus a plus x raised to the power a minus b. Your denominator is 1 plus 1, 2 plus x raised to the power b minus a plus x raised to the power a minus b. So both are same, so you can cancel because exactly the same number. So it gets cancelled, and which is equal to 1, which is equal to your right hand side. So this is how you prove question number 12. Now I move to the next question, question number 13. Question number 13, part 1. Here you have to find the value of n. So you can solve both the sides simultaneously. It is a multiplication sign, so I add them. So 12 minus 5 plus 2n plus 1, and this side is division sign, so you have to subtract. So 12, 13 minus 7. It is 12 minus 5 plus 1 gives you minus 4 plus 2n is equal to 12. 13 minus 7 is 6. Now when the base is same, we can write the exponents as equal. So when the base is same, you can write the exponent as equal. So it is minus 4 plus 2n is equal to 6. You take the minus sign 4 this side, so it becomes 2n is equal to 6 plus 4. So 2n is equal to 10. So n is equal to 10 divided by 2, which is 5. So n is equal to 5 is the value of n in question number 13. Question number 14 says simplify. So simplify, let's start with. First, you see if the numerator you can multiply, when in the denominator you can open the bracket. So it is x raised to the power 2n plus 7 multiplied by x raised to the power 2 into 3 is 6n plus 2 into 2 is 4 upon x raised to the power 4 2s are 8. So it is 8n plus 4 3s are 12. This 2 you can add because there is a multiplication sign. So it is x to the power 2n plus 7 plus 6n plus 4 upon x to the power 8n plus 12. When we add 2n plus 6n, it gives you 8n. 7 plus 4 is 11 upon x to the power 8n plus 12. Now division, same base, so the exponent goes up. So x 8n plus 11 minus, when we take this up, all the signs will become minus. It is minus 8n minus 12. 8 and 8 gets cancelled. This is x to the power minus 1, which you can write it as 1 upon x. So 1 upon x is your answer. This is all about your exercise 2b. Homework as usual. The remaining questions will be your homework. Whatever doubts you have, whatever queries you have, we can solve it during the online classes. Thank you, class.